Hello students, in the previous video we have learned how metal react with air or how metals react with oxygen in particular. Now we shall move forward and learn how metals react with water. Generally, if you take a metal and allow it to react with water, it produces metal oxide. It produces metal oxide along with hydrogen gas. Alright, so this is a standard form. Metal plus water gives you metal oxide and hydrogen gas. Now this is a general equation only, and for particular metals, for different metals rather, the reaction will vary. For example, in some cases the reaction will be highly exothermic, highly violent. In some cases it will be less exothermic, and in some cases you need to take hot water. In some cases you need to take steam, and there are some metals also which not at all react with water, right? So what we are going to do now, we are going to study all those metals one by one, all the particularly important metals one by one, and try to see how they react with water. So let's start with the highly reactive metals like sodium and potassium. Okay, now sodium and potassium, when they react with water, the reaction becomes violent. That means it is highly exothermic. Let me write a chemical equation for you. So if you take sodium and allow it to react with water, if you remember the general form was metal plus water, metal oxide. So it will give you a metal oxide Na2O plus hydrogen gas, that is H2. Of course the reaction is not balanced, you can balance that one. Now this is the metal oxide Na2O. The interesting thing about this one is that this is water soluble. Alright, now since it is water soluble, what will happen now, this Na2O will again react with water because it is water soluble. You understand water soluble, right? And this will now produce NaOH plus H2 is obviously there, and it will produce a huge amount of energy, right? Now because it produces huge amount of energy, this is exothermic. Alright, highly violent or highly exothermic. Now this is a very interesting property that you have to learn over here. Because it is highly exothermic, the energy that is evolved, because of this energy, this hydrogen gas catches fire. This hydrogen gas catches fire because of the energy, right? So hydrogen will get evolved and will burn immediately because of the high amount of energy that is being released. Same is the story for potassium also. Whenever potassium reacts with water, it produces potassium oxide. That potassium oxide is water soluble, so it reacts with water again to produce potassium hydroxide. Again it is highly exothermic, so the hydrogen gas that is being evolved will catch fire immediately. Alright, now let's, after sodium and potassium, now let us take the case of calcium. The reaction of calcium with water is less exothermic. As you can see over here, the reaction goes like this. Ca plus H2O gives you CaOH whole 2 plus H2 plus energy. H2 is a hydrogen gas. The calcium hydroxide is being formed. Now interestingly, this is less exothermic. Let me write it for you so that it's clear. It's less exothermic. So because it is less exothermic, the heat produced is insufficient to burn the hydrogen gas. So the hydrogen doesn't catch fire, and it stays over there. Now it stays over there. Now this part is very interesting. Please stay with me, try to understand this one. So when the reaction happens, the hydrogen doesn't get burned and it stays over here, right? And the calcium metal, initially were here, and the hydrogen gets attached to this, the hydrogen, the green colored one, the hydrogen gets attached to the calcium metal particles, and as a result of this, finally what you have the calcium particles floating on water like this. Why calcium is floating on water? Because along with the calcium there are the hydrogen molecules are being attached with the calcium, and that is why the calcium molecules are floating on water. Alright, so this question is being asked many times in exam. Why calcium floats on water? The reason is the hydrogen gas that is being produced stick to the surface of the calcium particles or calcium molecules, so that is why calcium floats on water. Alright, the next metal we are going to discuss is magnesium. The reaction of magnesium with water is special in the sense that when magnesium is allowed to react with water, it does not react with cold water. Rather, this water has to be hot water. Then only magnesium will react, and of course it will produce magnesium hydroxide, MgOH2 plus hydrogen gas. And you have to notice something over here. There is no heat released, there is no plus energy. That means the reaction is not at all exothermic. Alright, now in case of magnesium also, when the reaction happens, the magnesium, because there is no energy, the hydrogen will stay and it gets attached to the surface of magnesium, and that is why magnesium will also float on water. So calcium and magnesium, these are the two metals that floats on water. Alright, next up we are going to take some elements like aluminium and iron. The next we are taking elements, metals like aluminium, iron and zinc. Now why you are studying them together? Because when you allow these elements, let's say aluminium, to react with water, it doesn't react with cold or hot water, rather you have to take steam, right? And one more thing, it won't produce metal hydroxide, rather it will produce metal oxide only, and it will produce Al2O3, and obviously hydrogen gas will be evolved, right? In the previous cases, sodium, potassium, magnesium, calcium, we had metal hydroxides. Here we are having oxides only, because this oxide, this aluminum hydroxide, is not water soluble, so hydroxide is not formed. Similar is the case of iron also. If you allow iron to react with water, the very important reactions, this often comes in exam, so that will give you iron oxide, that is Fe3O4 plus hydrogen gas. Alright, so this condition is very important. You need steam for the reaction to take place, and obviously it is not exothermic, there is no release of heat or energy. Next up we are going to discuss about some metals that are very less reactive, like lead, copper, etc. Next we are taking a set of elements, metals, particularly lead, copper, silver, gold, etc. Now what is the specialty of these metals? These are low reactive metals, they don't react often, and as a result they don't react with water also. So you cannot have this reaction Cu plus H2O, they don't react under any condition, nor with cold water, nor with hot water, nor with steam. Alright, they don't react with these metals, and this is one of the reason why jewelries are made of silver and gold, because they don't react with water. Imagine the ornaments you're wearing, if they react with water it will corrode very easily, right? And that is why jewelries are made of silver and gold and copper, etc., so that they don't corrode easily. Alright, so we have discussed this topic, how metals react with water. Next up we are going to study how metals react with acids and bases.